Hello and welcome back to Compiler Programming. Today I want to tackle function overloading. So right now we can have these nice functions. It can be one argument, no arguments, multiple arguments, everything is great. But if we have something like plus, it would be very nice if we could have multiple versions of it. This one actually is not really interesting, but there is a 32-bit version. There should also be S8, 16, 32, and 64 versions at least, right? And users should also be able to, at any time, just add new overloads for plus. So let's make that happen. Okay, so we say you should be able to parse and run functions with overloads. And this is what we're going to do. So we are going to say plus is 32, 32, 32. That is good. Then we have plus S64. And we have plus S8. It also returns S8. Okay, then we need to have a way to test this, which means we need to have color S64 that returns an S64, and we basically say that you do plus of how should I do that? I guess it gets an S64 and it just doubles it. So like this. And then we say XX plus XX. So like this. We also do double S32 and double S8. And in reality, we'll have to look at the assembly probably to really know if that worked well. Maybe I could do some fancy stuff with the register sizes, but probably assembly is the only really good way to know. Or let's not do plus. Yeah, I'm being stupid. So the better way to handle this would be to have size of. Okay. So we have x, x, and x, and it always returns as 64. And what it does, it just returns hard-coded values. So we say it's gonna be 8, it's gonna be 4, and it's gonna be 1. Okay. And we still need the checker functions. So we say checker S64 doesn't accept anything, it returns 64, and it does size of actually it does need to accept a value, because right now we cannot really force a value to be a certain type. So for now I'll have to do this, which is okay. Size of x. Okay. So like this. This is gonna be S8 and S32. Okay, so now it's pretty good. I can do stuff like checker S64 value here, or I will just do it like this, and will straight up just say, how do I want to do it? I guess I will take this stuff, put it straight up into here, and this like so, and we have a 64 size. We'll wrap it in a block so I can just copy paste this stuff into multiple versions, and function type is S64 to S64. Okay, and I'm checking that the size is 8, and then I have 2 more. Here size is going to be 4, here size is going to be 1, and here I say that the type is S8, and here the type is S32. And then for the lookup we need 64, 32. Honestly, let's shorten it up and just have 32 and 64. There's no real need to have 3 values there. So like so and like so. Yeah, I like that. The only problem is that actually that doesn't work like that, because I need to actually extract them above before program end. I almost forgot about that, so that's a bit of an inconvenience, but it's fine. Checker R32, 32. Okay, that can be smaller now. Okay, and okay. Here I need to pass something. It doesn't really matter what I pass. Function type S32 to S64 undefined. Wow, that's interesting. Function type S32 to S64. S64. Okay, checker 32 is initialized but unreferenced. That's nice that it caught that. Let's run a test and see what's going on. Okay, did not find an acceptable encoding. It is move R64, R32. That actually is a bug in here, which is something we can pretty easily fix. Yeah, so this is actually incorrect. It should be like so. And we can actually move this thing up a bit. So here we say that so here it's interesting. So for a special case, because when you do this move, actually when you do move R32, R32, or R32 as a target, then it clears also upper bits of the register, so you don't need to do signed extended move. And in fact, if you do signed extended move, so this SX, it's much slower. So the better option would be, I guess, to yes, so this is how I'm gonna handle this. If we do this, if the target type is register, if source size is 4, then here's what we do. value star target with, or actually I will straight up do operand adjusted target is what? Well, type is operand type register, and then is it reg? Let me take a look quickly at the operand definition. Operand. Yes, reg is register, and here they are. So I can just say that byte size is 4 and register is target operand reg. And then I will say that this is where you're moving and you're doing a regular move. Yeah, that sounds good. Let's see if that works. Okay, it works in the sense that it found encoding and it didn't seem to break any other tests, but we have this broken test of overloads, and here's why. So when we do scope define value, have define value and define lazy, we basically need to be more careful about what happens here. And we need to do the following. So let me just quickly check what is the lazy value. Entry type is this. If it is lazy, it is a token. That is fine. I guess for lazy values, it should not be a token, but rather it should be an array of token. So we say array token pointer token. That will break a bunch of stuff, but that's fine. So lazy, and here we will need to handle some stuff. So what will it do? Entry. It's interesting that this one didn't break. Anyhow, array token pointer tokens is is entry. Actually, it shouldn't be called tokens. It should be called tokens. Okay, that causes some issues, but maybe it is just because of this parsing error. Array token pointer tokens entry tokens for u64 i0 I is less than the array length of tokens plus I. So how do we deal with this? Well, we say value star result is 0. We assert that we have a result. Now we are ready to do this stuff and say if not result, and it's very straightforward, right? If we don't know what it is yet, we just say that it is whatever this thing says it is, and we should say token star token is dynamic array get of tokens I. So this would be now token. Otherwise, this becomes very interesting. So if we found that we have multiple things, we are only allowing overloads for functions. So that means that here we can say that assert of result descriptor type is descriptor type function. This needs another star, more stars for everybody, and return result. If it is a function, then if we look into our value.h in a function descriptor, I believe somewhere here, descriptor function, there is this value star next overload. So this is what we're going to do. We're going to just say that value star overload is this stuff, and we are asserting that we do have overload, and we can say that here's how we're gonna do it. We're gonna assemble them in reverse order. So we say overload, descriptor function, and next overload is result, and result is overload. We don't really need this stuff because it will crash very spectacularly if it is 0 anyway. Yeah, something like that. Left breakpoint struct, use descriptor function. Is it like this? Yeah, okay. That is good. And this is what we need to do. Now here we have to be very careful because when dealing with dynamic arrays, it mutates the handle. That means that I cannot just do the following. Let's actually do it like this. Array token pointer tokens is 0, and then we say if hash map has yes, if hash map has scope map name. Actually, here I need to do the lookup. Okay, this is where it becomes slightly interesting because with overloads, I think I need to define them in the right scope. Okay, so here's the problem. Imagine that I have, let me think how best to illustrate what I'm thinking about. So say we have this scope lookup force, or actually let's do size of. So I will have this size of function, right? And it doesn't matter what it accepts. And we say return 4. Now imagine that in C I would also be allowed to so let's say this is S64. Imagine that I can in C define local functions, and I would say here that I define S8 and here do size of whatever size of 3, right? Technically, this thing is only defined in this scope, and I think I want to allow people to define functions in local scopes because it's just very handy. I think to not pollute the global scope and not pollute like even the file scope, right? If you can just extract part of this stuff in a function and eventually they're gonna be capturing, so you will have like proper lambdas and stuff, closures, however you want to call it in the language that you are used to. Yeah, what I want to say that this should work. That means that the whole lookup is going to be even more complicated than I think it will be. This is pretty going to be pretty crazy. For now, though, we can continue like this. So we'll say that if this is not defined in this scope, then we will deal with it in a particular way. So if this has, then I would say that tokens is naming actually hash map get of scope. Actually, maybe I do the following. Yeah, maybe that is fine. Tokens is 0. Actually, I can do probably like this. I don't remember my own hash map API, so we'll see if that actually works. Map name. If not tokens, tokens is hash map set scope map name dynamic array make of what? Of array token pointer, and that's that. And then we do hash map set. We do dynamic array push to star tokens, and we push in our stuff that we got, and then we need to set it to tokens. Yeah. So let's make this one a bit smaller. Oh, this is gonna be a bit annoying to deal with. I thought we would have directly the stuff, but we don't. So let's just do it from scratch. We say that scope entry star entry is hash map get scope map name. Okay. Now, if we don't have an entry, then we do the following. We create an entry. Actually, let's use has here. If hash map doesn't have an entry, we just add one, and then we say scope entry star entry is hash map get scope map name. Actually, even not that. I need to do scope lookup. Yep, this is what I need to be doing, not this other stuff. So scope entry is scope lookup. Okay, again, thinking about this. So we have overloads in one scope, and then we have possible overloads in nested scope. That means that when we try to define a value, we do only need to look up in the current scope. So this version was actually correct. And let me write this down before I forget. For overloads, we only check current scope and allow multiple overloads in multiple nested scopes. Okay, so this should be fine. And here we actually need to do, say, hash map set scope map name and entry. Okay, this is tokens. Now I can do the following. I can finally say dynamic array push entry tokens token. Okay, and now we don't even need to have the other stuff. Okay, hopefully that is what we want to have. Let's see. And here we go. Just like that, we now have overloads, which is really, really neat. Yeah, I guess right now I can't test the local function version of this, but well, let me think about this. I could make a test that will eventually get broken, but will work for now, I guess. Well, let's try it. So we'll create another test. Should be able to define a local function. Okay. So we say this is going to be called checker. We only need one in this test, right? And that thing will be function type void to a64. We get it with nothing, and here's like this. We say that checker result, or I think I call it answer in other places. So we say answer is 42. And here's where it gets funky. So we now have multiple statements, right? So I should be able to do something like local, and local is going to accept nothing and return s64. This also accepts nothing and returns s64. And then it just says 42. And here I will say that we call local. Okay, if we can make that work, that's gonna be very, very cool. So this is like so. Well, let's try to run and see what is gonna happen. Yeah, so what happens right now is we currently have different parsing rules for the module and for the body of the function, and I think that's going to stay that way for a while. However, there can be some intersections. So we have this token match module, and here is the function stuff, right? And I think I can just try to extract this into separate things. So I can say star void token token match functions. Yeah, something like this, and we'll see what we actually need to pass to it. I guess we'll need to pass a program, right? And we also need to pass this stuff actually doesn't yet use the new token matcher state. So that's also something interesting. Oh, this is even broken at the moment. It sort of uses state, but it sort of doesn't. It should do this. Otherwise, it would be very, very poor. State tokens, yeah, it should be like this. And yeah, this is the right way to do it. And here that means that we can pass in token matcher state star state. Yeah. And now that I'm thinking about it, I could probably even extract this whole for loop business at some point, but it's not what we are doing at the moment. So that is fine. State tokens. And we need to have this parent and source information. Okay, so we will pass the token, I guess. I think eventually it should go into the state, but for now, realistically, we are not using any of that. Like the whole parent stuff, I think it's only used during parsing anyway, so let's just, do that. And here we'll just take whatever, arrow. Yeah, that's fine. Here we also actually can do arrow parent if we want to. Yeah, that's fine. Okay, state tokens, state tokens. Okay, looks like we were able to extract this into a separate thing. And I can say token match functions state program. Okay, let me try to run this. It should get still the same failure, but the rest is fine. I would actually even comment out this function for a second so that I can check that everything is fine, and it looks like it is not. So state tokens, state tokens, state tokens. What about now? It's still not correct. Okay. Where is the issue? So we're not using token anymore at all, but it still complains. Where does it complain? I think that's because, yeah, that should just be a problem of the order of stuff. Yeah, that should be here. I believe at least. Yeah, okay. Good. So that is extracted. We can do let's just do it right now, I guess. So I'm gonna take token rewrite. I think that would be a better name for it. And then we have helper thing, which will be token rewrite. And we need to type def. So that is void star token rewrite callback, and that callback will accept token mature state and program, and this thing accepts token mature state program and it also accepts this callback. Okay, now we can take this stuff. Okay, this goes over to here. I don't need to say this bool did replace just. I guess I can just do the following. So this will be an infinite loop, right? We'll go from one thing to another, and here I will just do break, or we need this stuff. Yeah, so I have to say like start, and if callback of state and program go to start. Okay, so this actually is not void, this should be bool, and we don't need this stuff. We return true, and here we return false. Okay, let's see if that is better. I could probably also do this stuff as well somehow, but that can be done later as well. Well, here it should be state start index, and then so I will say u64i is state start index, like this, I guess. Yeah, this is also a candidate for figuring out how to deal with that. But for now, token rewrite functions. Okay, at least signatures seem to match. Let's try that. And it still works great. So that makes me pretty happy. And now this stuff is actually just the right thing. Okay, I can do token rewrite constant definitions. So that's that colon stuff, which we will now take out of here. And yeah, so this is what we want. Which ones? Yeah, so this is this stuff. We can do this. This is not continuous. This is now false. Okay. And here is state start. Actually, I'll just do the same as I did here. I will end the I. Okay. That sounds good to me. And we can take this and we can say token rewrite constant definitions. Let's see how that works. Works marvelously. Git add this just so that we don't lose this stuff, and I will need to take all of this and move it a bit above, actually quite a bit above, before token match expression. Okay, that still works, which is great. And now that we have token match expression, what are we going to do? That's actually quite interesting, because there is technically a difference between expressions and statements. I think for now I will not that's an interesting thing, because what happens right now is we just, when we have a definition, we remove everything, and that is okay. But long term, I think the better option would be to introduce a new token type for definition as well, or a new value, and replace the result with that, so that when we get it inside the statement, we will be able to tell it we define something. I will write a comment saying fix me definition should rewrite with a token, so that we can do proper checking and maybe pass it around. Proper checking inside statements. Okay, something like that. But that is not important at the moment. We'll just accept more programs than we should be accepting, which is not necessarily a bad thing, but it's something to think about. So I want to take these rewrites, I want to take them to the expression stuff, and I want to do that. Here we also have the thing where if so I will do a switch here now. So we switch on the length of the array. If it is 0, then I will just return void value. If it is 1, well, I will do whatever this thing was doing, right? And in a default case, I will return 0, and I will not even get to 0 because I will assert and say could not reduce an expression. Okay, that is actually a better way. So now we will also just handle this kind of stuff. So if we have an empty braces, that will just mean a void value. Okay, program undeclared identifier. That is, yeah, that is interesting. Does the function builder have a reference to the program? Yes, it does. So that's very handy. I can say builder program. And as far as constant definitions, so this is where it's interesting, right? So functions should be rewritten basically first, but the definitions should be rewritten last. Okay, let's see what that brings us. Well, it doesn't break anything. That's also good, but we actually have this test commented out, so we don't know if that works. Let's see if it does. And look at that. So now we have local functions, which is great by itself. But the reason I was even going to this is this case. And I will need to do this. How do I even test this? I guess I take, yeah. So what I will do is I will do this size of, I will take this size of, and no, I'll take this one into here. So we'll have a checker, and then we will do it like this. Okay, there are actually two situations that need to be checked. And one of them will just work, which is, this is what I'm trying right now. So let me try to show you. So this should just work. Checker, checker, checker. Checker S32, checker S32 to S64, size is 4. Is local overloads. Okay, so this, as expected, this works. Also, it should work like this. I mean, the test will fail, but it should not explode. Yes. Okay, so that's fine, because what happens is we have 32-bit value, right? 32-bit value is implicitly castable to 64-bit value. So this is the overload we end up calling, and or it's the only function that we have. So this is perfectly fine. But the interesting one, and the one that actually is gonna cause more problems in a different place, is the other way around, where here I would say 64, right? And here I would say 32. Yeah. So this thing will now do the wrong thing. It will return 8, but it should return 4. And in fact, there are two parts to this problem. And before we tackle this one, I will actually make the other test fail by showing what is the problem. And the problem is the following. If I do it like this, I think, then we should have an issue. Probably. Yes. Yes. So what happens is, because we are allowed to implicitly cast sizes, when we do overloads, we need to find the best match. And that means we need to change call function overload. The algorithm that is used here needs to change. There is same value type or can implicitly move cast, and we need to change how we are doing this. If match call function overload to call. So this is okay. This is how it's gonna work. We'll have yowza. So here's a whole problem. Say you have S32, S8, S64, and S32. This is one overload. And another overload is I actually can have, yes, something like that. Yeah, like this. And what we are trying to call it with is S32, S32, and S32. None of them, these both functions are not the right match for this call. However, this one is a better match, probably. Right now the rules are, I guess, are pretty straightforward, but for the for for later on, they will be getting more complicated. The point is that I cannot just distinguish exact match versus non-exact match. I need to keep the score. Like if you were doing any CSS stuff at some point, you know how CSS selectors have a score, and it determines their priority. So this is what we will need to do. So I guess let's do it. We say type def struct overload match score, and then we have S32 exact matches, and then we have cast matches. And what we need to do is the following. Let's do it like this: value star value. So we start with there also is a problem of optional arguments, which we don't have at the moment. Okay, here's what I'm gonna do. I'm just gonna do the same thing as mostly done in CSS, which is you just have a score, and let's say that exact match scores you 10,000, and inexact match scores you 1. So we are kind of separating by several orders of magnitude exact and inexact matches, and that means that you would like they should not overlap. Like if you have a function with 10,000 arguments, you have a problem anyway. So here we say enum score exact is 10,000. I can even do 100,000. And then score cast is 1. And what I want to do is now I say overload match is 0, right? And here I can say that we have U64 score is 0, or I will start with yeah, we do 0, I guess. Oh, if match, so if not match, so again we'll have to do a bit of goto. So if we have not matched, we'll just say go to next, I think. I hope that it does what I want it to do. Actually, no, it wouldn't, because we will not go to the next one. So that's a bad idea. I guess we'll do it like this. Next is going to be here, which is not allowed. I really don't like nested loops in in C. Okay. This is what we're gonna do. We're gonna say U64 calculate arguments match score of this stuff. So we're gonna get descriptor star function, and we're gonna get array value pointer. Actually, we can, let's do it like this. It's fine. So here I say U64 score. Actually, we make it S64. So the problem is I need to distinguish not a match at all. I need to, and because if we have no arguments, we'll basically have a score of 0 because this loop will not provide any value. So I will say S64 score is 0, and if we didn't match, then I will return -1. Okay. Now, if we matched with this stuff, so this will be like this, I guess. If same value type of target arg, source arg, and score plus equals, so we'll move this stuff here, score exact. Here we will do score cast. And now I can say 64 score is calculate argument match score, descriptor arguments, and I say if score is -1, we just continue like that was not a match. If it was a match, I'm saying that here I can actually say score is also -1, and then I can even fold in this condition saying that if match score, if score is more than match score, so we could technically have two overloads that have the same score, I guess, and in that case probably I think the right way to do is errors. So as a fix me, think about same scores, but right now that's not an issue. We say match score is score, and match value is to call, right? Yep. At the end, we do the following. We say if match value, match value. Okay, I'm missing stuff here, and here I need to say return score. Yep, that looks good to me. Well, let's see if that fixes the test. And it does. Great. Great stuff. So now getting back to this new test, it should also work, but right now it doesn't, because right now when we're doing a function lookup, we this is kind of interesting. At the point where we are doing the function lookup, we will need to tell the resolution setup to be in one of two modes. We either will need to, or maybe there is a better way to do it. So somehow, when we are looking up a value in the scope, we need to know if we are looking up the function call or we're looking up something else. Because if we are looking up a function call, we need to gather up all the overloads from all the scopes from this point and up. But if we're looking up the regular value, then we just need to find something in the closest scope to us. And I think the way I'm gonna do this is actually quite sneaky. How to where is this lazy stuff? Scope, lookup, force, yes. So yeah, this is this is our main loop where we are gathering up the values. Actually, this thing also doesn't do something really important. Oh, this was kind of nasty the way it was working before, because when we get a lazy value, we shouldn't just return it. We should also say, basically need to rewrite the entry. We need to say star entry is scope entry and type is scope entry type value, right? And then value is result. This is also quite important, because previously if we would call a function twice, we would create two functions, which is not great, I'd say. So for now, I will disable this test and try to run all the previous ones to make sure that the result placement works. It does. So we can continue with this thing, and here's what I wanted to do. So if we ended up with overloads, I need to how should I do this? Let's just, I will write just the most straightforward version, and then I will think if there is a better way. So if we found a function, then we say scope is scope is scope parent, while scope is scope parent. Maybe I will actually do it this way. Do So the idea is, if we realize that we looked up the function, then we need to go all the way up and gather up all the overloads of the function. Actually, this is not just a thing about lazy ones. This is a thing about everything. So I need to do the following. Say value star result. Result is entry value. And here we have results. Yes, so this is like this. I can assert that we have a result and return result. Yeah. Okay. So that's good. We don't return here. It's fine. But the idea is, now we do this. So we look up in the current scope. We realized, oh, we looked up a function. So we should go all the way up the scopes and gather up all the functions into overloads. And the way this is done right now is kind of not great. Because we just chain them together. Well, I guess that's fine. I guess that's fine. Yeah. I think it will work. Okay. So we do start result. Okay. I can do this value star, maybe overload, scope lookup, scope. What am I looking up? Name, right? Scope name. If not, maybe overload. I shouldn't be doing scope lookup here. I should be doing this thing. Same, if not scope, then break. For functions, we need to gather up overloads from all parent scopes. Okay, so value star maybe overload, scope lookup, nope, entry result. If not result, we continue. If we do have a result, we say that how should I do this? Well, I can cheese it a bit and say that if we have it, so if we don't have it, continue. Otherwise, I will say value star parent overload is or just like this. Overload is what is scope lookup force of scope name and builder. Okay, And if we found an overload, then um, yeah, actually, this is where this whole just with next is not great. So the last one should not have an next. This is slightly mind-bending. So I'm just trying to figure out if I will have issues and who needs to set their next. I guess the result needs to set their next. Before I do that though, I need to assert like this, and I say result is yeah, result and descriptor function next overload is overload, and result is overload. No, that doesn't make sense. Da, 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 da. Wait, will this even do what I want? So I realized that in my scope I found a function. If that function is lazy, I go in and gather up all the overloads, and in this scope I have a perfectly working overload set, which is just I know what I need to do here. I need to get all the way to the end and attach the overload there. So, okay. Value star last is result, while last next last is last next, and then I'm adding to last one. So last descriptor like this, I guess. Yeah, well, we have the next one, we go, otherwise we add it as overload, and yeah, I guess this is fine. We don't need to do anything to the result by itself. And in fact, this thing can even go over here. We don't need to reset it. Okay, this is pretty shaky, but let's see how it works out. Okay, I guess we have an infinite loop somewhere, I think. shouldn't. Like, Event mass session. Let's check it out. I'm not sure what's going on. I guess I can very easily figure out if this is an infinite loop by just printf here. We have an ever-ending list of here. No, it's actually not an infinite loop, which is great, but I think I had a problem. Okay, let's try to find out what happened. Okay, so I do have an infinite loop, but it's not here. It's kind of interesting. I think I can just break. So where are you looping? So basically, I managed to construct an infinite loop while doing this stuff, which is I thought shouldn't be really possible. What is going on? Okay, just verify that it is this part that is messing it up. It is. Well, let's reread this and then try to debug it. We start with a parent scope. If there is no scope, we stop. If there is no such name in a current scope, we just continue to the previous scope or to the parent scope. Now, we try to do this lookup force. This should give us a new overload. We go to here. I don't really see what is the issue, to be honest. Maybe I'm just not understanding what I'm doing, but I don't really get it. Source versus here. Well, I guess which test is going crazy? It is this fourth test in here. So able to parse and run a plus function, and this multiple function definitions is what is exploding. It's very interesting. So it's not even overloads that are messing this up. It is way before that. Is it the way I'm doing this? But no, this was passing just fine. Okay, this is just very, very strange. Okay, let's just see what's happening. Okay. Pink, pink. Uh, which test is it? Multiple function definitions. Okay. We shouldn't be getting into here. So what is the scope? I have... I can see the arguments to the function now. Okay. Let me do this so I can easier track. Parent is scope. This just should allow me to easier get into... Okay. So scope. Okay, now I'm really confused. Ah, no, okay. It's fine. So we have parent and we have a map. Do I have the same map? No, scope make has a different map. Okay, so that's not what is going on. Get back. Okay, now I'm very, very confused. We have a scope and we have a parent. Inside the map, we have a bunch of entries, which is not very easy to digest. We have 4 entries in the scope, and we have 0 entries in this one. Oh, yeah, my logic is actually flawed. Now I get exactly what's going on. So what's happening is, actually, do I get what's going on? So we have 2 scopes. We have a local one and global one. We find a value in the global one. Yeah. So we find value in there, and then we this is yucky. So we find this value not in our scope, and that means that I need to figure out in which scope I found this entry so that I start search from the parent of that scope. I think the best way would be to do it like this. And I can do the following. Result, yep. Result, break, otherwise scope n, okay. It's actually not the result, this is entry. Entry. Okay, now it is better. So I can to this and it should be fine, because now scope will return to actually the one where we found the thing. Okay, so that's better, I guess. Or maybe not. What? Now it doesn't find it at all? Line 114. So this definitely this assertion that is going off, and in the first function. What is the difference between these two things? Get the result, hashmap gets. What? This is even more strange than before. Maybe I'm just getting tired. Okay, scope entry is 0. Yeah. No, I'm getting tired. Great. So that is what I actually wanted to have, and looks like we even get the right answer here. Great. That's definitely it for today, but I think it's really awesome progress, because now we have overloads, we have proper matching for overloads with the scoring, which is great and was not available before. I also have local functions and local functions with overload and all the jazz in all different varieties. I think this is really, really nice. That would definitely be it for today. So thank you very much for watching, and hopefully see you next time.